Okay, so welcome everybody. We're going to get started here. Some folks are still trickling in, but they can catch up later. So welcome to our April webinar on understanding FRACAS. We're all very excited to learn more about this FRACAS from Ricky Smith with GP Allied, so we thank him for joining us today. Just a couple little bits of information. So, UE Systems, we've been around for 40 years helping folks improve reliability through the use of ultrasound, and through that time we've been able to come across great colleagues like Ricky and the other folks at Allied who really drive home the importance of reliability and have really great tools and tips to share, and so it's great that we're able to do these webinars with them. We're located all throughout the globe with offices in Mexico, Canada, South America. You see the list there. So we hope that if anybody has anything they need, that we can be there to help out. And it looks like we've actually got a pretty good international group of attendees joining us. So it's a great way to really be able to bring folks together on these webinars. If anybody's interested in getting some more information from us about our different products and software and different applications that ultrasound can be used for, just pop a note to me in the chat window and I'll be sure to email this to you. Just a great tool to learn some more information. And before I welcome Ricky, just a couple housekeeping. If you do have questions, and we definitely will get to some Q&A at the end, you can see you've got an opportunity to type questions into the box. So just go ahead and write those in, and we might even stop Ricky along the way if we get a question that makes sense to ask him. Otherwise, we'll do those at the end. We also are recording this, so we will be putting this up on our website along with all of our other webinars, so you can access this later or share it with a colleague who might not have been able to join in. We will email everybody once this is available online, so you'll get a note from me about that. Without further ado, though, let's pop this screen over to Ricky and find out what's going on. All right, and there you go, Ricky. Thanks so much.
Thank you. Thank you, everybody. We're going to talk a little bit about FRACAS, which is really failure reporting, analysis, the analysis that we do in Corrective Action System. I'm going to keep this very simple because this is where we really need to start at in most organizations. First thing we talk about is what is a failure? Well, a failure is an unacceptable condition to the end user. That could be rate, it could be it's broken. There are many things that we can considered a failure. And what is FRACAS? Well, FRACAS is a process by which failures can be reported in a timely manner, analyzed so that corrective action can be put in place and eliminate and mitigate the recurrence of a failure. So essentially, we want a process in place that says when we have failures, whether it's multiple failures or a large failure, we have something in place to say this is how we're going to resolve it. So the goal of FRACAS, to help an organization better understand failures, is the reporting required to identify failures and the actions required to eliminate or mitigate failures. Now, I'd like to show this one. I mean, we have a choice. We have on this what's called the I to PF curve. You got where the equipment is installed. P is where the PF curve begins. And this is where failure begins, at P. So we could either manage a failure or we can eliminate the failure to begin with. And FRACAS wants to move it from failure management to failure elimination. So when we look at a simple proactive workflow model, most of our work should be coming from PM and PDM, from our condition monitoring. And that work now goes to planning the results from PM and PDM. We plan the work, and once we plan it, then we schedule it. And once it's scheduled, of course, work execution. Now here's where it comes into some of the problem. Are we executing the work correctly so we don't have failures? And then the work order closeout. Do we put the right codes in? Do we put the right information in so we can do some analysis later in case we do have either rework, repetitive failures, or whatever. We can find out what's going on. And then FRACAS, the Failure Reporting, Analysis, and Corrective Action System we're talking about today. And this is the continuous improvement loop. This goes all the way back to our PM and PDM program. So if we have failures, we may need to adjust our maintenance strategy. Like I use the analogy, if you perform and preventive maintenance on equipment that continues to break down, something's wrong. We need to go back and look at our maintenance strategy and adjust it accordingly. So what are some of the causes of failures? You know, no repeatable procedures, not executing PM to specification, maybe we don't even have a specification, not performing corrective maintenance to specification, personnel not trained, whether it's in skills and maintenance or reliability, because we need personnel that understands all of this. And then we go back up to the specification, you know, with the skills and all. If we do not know how to torque fasteners, whether it's electrical or mechanical, we got a problem. And that's a very simple one, but there are more complex ones that we need to be concerned with. And parts not stored to specification. The storeroom is a terrible place to cause failures. Failures can begin in the storeroom. Not using the right tools. Best lubrication practices unknown. And then root cause analysis not applied or not known. Or sometimes we use root cause analysis, what I call chasing failures. We're not really solving the root cause of the failure. We're chasing failures. And then no auditing maintenance activity or work. So is there an auditing process that says we are following the process for preventive maintenance or condition monitoring? Is there a process to audit? Are we following those corrective maintenance procedures or not? Is there an auditing process to ensure that the work order codes are in the maintenance software when we close them out? These are all questions that we have to have an auditing process in place. So just some known best practice data. 15% of maintenance work is execution of PM. 15% is the results of PM execution. Now, I always say PM and PDM is really a controlled experiment. We put equipment in controlled state, we do something to it to give us an outcome. And then 15% of maintenance is execution of PDM. And now, this is different from PM. Now, you see our results went from 15% from a PM execution to 35%. This is where most of our work should come from. In emergency work, less than 2% of labor hours. Planned work, 90% of our work should be planned. And schedule compliance by day, by week, 80%. Some people say we don't do it that way. I don't like that. That's okay. However you want to do it. I'm just showing you what's known best practice. Some of you may or may not have seen these failure patterns, but very simple. Age-related failures are very low, 11%. Random failures, that means they can happen at any time, are very high. And I have to have people tell me, well, I don't agree with this Nolan and Heap steady failure pattern. Okay, no problem. Show me your data. Show me your failure patterns in your organization. And I have yet had anyone show those to me. So when we go to the infant mortality, which is 68% of failures, this is what I'm concerned about, because I've got this slope here, and this slope means that we're having some type of infant mortality, whether we're installing the part wrong or we're not following specification, we don't have repeatable procedures or whatever it is that's causing this infant mortality. I'd like to cut that slope off is what I'd like to do. FRACAS can do that, can help us go in and identify, you know, what are those causes for that infant mortality. And I always ask the question, why is infant mortality so high? Maybe because we do not apply the PF curve philosophy. And I found out the other day through a study that only 2% of people truly understand the PF curve, which I find very interesting. So just show you PF curve with priorities, okay? We have point P. That's where failure begins. Now we can't, it's very hard to identify a failure the immediate time it starts, okay? So along the way we have predictive maintenance, we have preventive maintenance, and run to failure. Predictive maintenance is going to identify that failure earlier than preventive maintenance will. And then what we're trying to do is not go to catastrophic failure unless our strategy is run to failure. A lot of people have the strategy run to failure. They just don't know it. So when we look at priorities, this is where priority 4 and 5 is where I want to identify defect or abnormality. I want to find that failure and then plan and schedule the work. Now, we've got another area, priority 1 and 2, and this is our reactive area. This is where we're having the problems at. This is where we don't want to get into because we get so close to a failure. The failure curve is not always like this. In fact, it's never like this. It gets to a certain point, it drops off, and the equipment fails immediately. So I'm taking that PF curve now, and I'm going to talk about work priority distribution because I think it's important that we understand, the reactive work is what causes our failures. So if we say priority 1 and 2 work is reactive, it should be very low. Priority 3 through 5 is proactive work. Very simple. That's where our work should be coming from. For PM, PDM, this is corrective preventive maintenance. This is corrective work coming from PDM. Now, we move to the PF curve of managing proactive maintenance. We have point P, point F like we spoke about before. Let's say ultrasound identifies a defect in priority 5. So we move over to the right. It says defect detected, work request initiated, work request received, converted to work order, job research, necessary parts identified, purchase rec entered and approved, parts ordered, job plan completed. Now you notice we're moving down the PF curve. So we're moving down the PF curve, and we don't want to get past this red line I just put up there. We don't want to get past priority 3. So we go to parts received, parts kitted. Now we're in priority 3. Parts received, work order released for scheduling, job scheduled, job completed. We never got close to failure. This is what we want. We don't want to get close to failure if that is what we want. If it's a critical asset, we probably do not want it to fail. And something I've always said is, it isn't what you know that will kill you, it's what you don't know that will. And we know that. Now, in FRACAS, or anything, it's all about the data. It's all about the data. So let's talk about data. High variation with our data. So, variation can come from our maintenance process. If we're not planning the work right, we're not performing scheduling right, we're not scheduling things properly, and even if we don't execute our PM and PDM correctly, we could have problems, and that's high variation in our maintenance process. And then we go down, a PM program not effective. Definitely will cause us a problem. Variation in PM compliance. Hey guys, so 30-day PM, you got all month to get it done. Just get all these PMs completed so we take care of our PM compliance. Boy, this is a big mistake. Big mistake. And the PM program not focused on specific failure modes. Failure modes is how equipment fails. That's what we want to look at with our preventive and PDM program. Specific failure modes and their causes. Then repeatable corrective maintenance procedures not available, or if available, they're not used. And what I mean by that is step-by-step procedures with specifications, with standards that tells us how we do the work. And people say, well, I don't need those procedures because I've been performing maintenance for 30 years. I'm a skilled craftsman. Well, great. Can you remember everything that you did? No. It's not possible. Humans are full of error. So we have to put the procedures down. We have to develop procedures so we all do things the same way. The worst thing that could happen as part of FRACAS is we find out the procedure is not correct and we modify the procedure. Now we have no more failures. But without corrective maintenance procedures, we're dead. Storeroom I talked about this earlier, death trap for parts. And a lot of times I see little or no PM on critical spares. I know this may surprise you, but I have been in plants where I go into storeroom and none of the electric motors, especially the critical ones, have never been rotated. They're supposed to be rotated every 30 days, 1 1/4 turns. And say, well, I don't have the maintenance people to do it. If you got someone in the storeroom, a PM could be sent to them saying, rotate shaft 1 1/4 turn on this motor. Not a problem. ISO 14224. ISO 14224 at this time is the only document, ISO document, that focuses on maintenance and reliability data. Okay, if you don't have this document, I recommend you go online and find it. Now, you will have to buy it, but I tell you, the more you look at ISO 14224, the more you learn about failure data. The more you learn about how I should have my maintenance software operated, how I should be managing my maintenance process. It's a great document. Now, in that document is what we call maintenance taxonomy or equipment taxonomy. Equipment taxonomy is simply a systematic classification of equipment into some kind of generic groups based on factors that are possibly common to several of the items. So I've shown you here, this is basically your equipment hierarchy. Production area number 2 is at 5, section system level. Our electric motors are at component or maintainable item level. Now the effects of good quality data. So we have good data. We're looking at mean time between failure. This chart, motor, MTBF, motors mill wide, and this is actually a real chart over 2 years. And you look to the right, you see they're using ultrasound lubrication. I tell you, this is the only thing they did. It was 900 electric motors, and here's the results of it. Cost went from 1.3 or 1.4 million down to about 700,000. A tremendous decrease in cost, tremendous, just by ultrasound lubrication. I think, man, if you got bearing failures, you need to think about lubrication as part of your problem. So I want to talk about just some KPIs real quick. Asset health. This is the percentage of assets with no identifiable defect are green. The ones that we have a defect, abnormality, in other words, they're past P on the PF curve, is in red. So the next KPI, mean time between failures. All it is the number of failures that we have divided into time. I recommend, if you're going to measure mean time between failure, that you divide the number of failures by week into time. Don't do it by day unless you've got a lot of failures, because it won't look like anything that you can understand. So here's the MTBF example reporting by taxonomy. So we've got the line 401, which is really production area 2. So the area level MTBF, it looks like a lot of noise. It's just up and down, up and down. Don't know what that means. I've got to break it down to the component level to determine where the problem is. So when I go down to the next level, which is electric motors, it says on here, but really I'm going to look at electric breakers. I'm seeing the mean time between failure getting worse. Then I've got to go to my next KPI. And this is where I compare mean time between failure to equipment condition report. You know, which electrical circuit breakers are we having the most problem? And when we have the problem, what is the problem? So we're moving from one metric to the next. This is part of this FRACAS. Identify what the root cause of this problem. KPI number 4, equipment condition to equipment detail. Now I've taken this equipment condition report, I'm looking at the most critical failure that I'm having, or critical problem that I'm having, and then I'm looking at the specifics about it. What is the problem? What is the problem? You don't have to have a formal root cause analysis process to determine the cause of this problem. Because here, KPI number 5, MTBF to route compliance. If we look at our route compliance for electrical breakers on electrical IR is 37%. We got a problem. we got a problem. In other words, our electrical infrared inspections are not meeting compliance. Someone's not getting to all the equipment for whatever reason. I don't know why, but we need to find out. And you know, all of this affects cost, no doubt about it. Everything we're talking about affects cost. Because if we say it's not about cost, it is. Talked about earlier about data accuracy. Now, this is a key one. You know, if you want to have accurate data, you need to develop a process map saying, how do we close out the data? The first time that I developed one, I tell you what, I found it was a little bit more complex than I thought. But once you develop a process map, then I'm going to develop a RACI chart. This determines who's responsible, who's accountable, who's consulted, who's informed on different parts of the process. So in this case, accountable, the buck stops here. That's who we go to if this part of the process is not working. Responsible, that's the doer. That's who does it. Consulted, keep in the loop. We want two-way communication with that individual. Informed, we'll send you an email. But it makes it clear what our roles and responsibilities are in data accuracy, or anything. Now, the next thing we're going to get into is the 7 steps to a successful FRACAS. Determine your end goal. I know you've heard this many times. You know, what is it you want? Identify bad actors, maybe? Determine the equipment causing the most pain, maybe? Eliminate failures on critical equipment? Those are things that we have to determine. What is our end goal for FRACAS? Okay, let's say it's eliminate failures on critical equipment. That means we're going to have to put in place a process that's going to be able to identify those failures on the critical equipment down to the level that we can understand what the problem is. And we may have to apply root cause analysis on specific bad actors in that critical equipment. Because you know, most failures that we find are linked together. So if you're having a failure on a motor over here, motor over here, motor over here, some of their failures may be linked together. And if I can find out what that failure link is, and if I resolve that, equipment reliability on those motors go up. Next is create a data collection plan. So we know what we want to collect. Now we want to determine what data we need to collect. So we want to know what measures you want to use. It could be MTBF, okay? Could be mean time to failure. You have to determine that. You know, in ISO 14224, this is some of the information that they have in there, you know, that needs to be collected to give you the desired results. That's why I say that ISO 14224 is a great place to go to. So if we look at down at the bottom, a number of RCAs triggered, number of RCAs completed, go all the way down to number of corrective actions required. So we're going a little bit further. We've corrected the action. Now, what's happening? And down to the bottom, a number of repeat failures for which corrective actions have been implemented. I'm a little bit different about measuring, like a good metric would be rework. You know, rework to me should be measured. If I have a failure on that asset within 90 days, then that's rework. Some people say, well, you know, SMRP says 30 days. Okay, that's fine. I say 90 days because the problem is unless we perform root cause analysis and identify exactly what that failure is, what's the root cause of that failure may occur again and we call it something different. I just want to know if it happens in 90 days. That's all. I've done this for a lot of organizations, and I'll tell you what, it brings a lot of value. And then determine how the data will be collected. You know, there are different types of data that need to be collected. We need to determine how the data will be collected. You know, will the failure data be collected through our, you know, enterprise asset management or CMMS, some automated system? Because there are automated data systems that can give us that information too. Or by using checklists. Some companies are still back in the caveman days breaking rocks. And then determine how the data will be analyzed. We have to know how we're going to analyze that data. You know, and I say the best bet is probably to start with a Pareto analysis. That's the easiest way to start. And just just make sure to remember that the data analysis, where to apply it, okay? You can have just do it, JDI, I call that a JEDI, just do it, you see the problem, solve it. Root cause analysis we may apply, or we may apply reliability centered maintenance to identify what the problem is and what's the solution. What's the correct maintenance strategy we need on this equipment, because evidently it's not right because we're having failures. And then until we don't fall victim to analysis paralysis. We got so much information we don't know what to do with it. Start simple. Do not get complex immediately. Start simple. You may never get complex. You may be happy once you get failures under control to a certain point. You say, I'm good. Don't need to go any further. And here's a good example of one. This was when I was over in Qatar. We determined that in this plant we want to know the number of failures by area, and then we want to know the number of failures in that each area by equipment, and then we want to know the number of failures by component or part on that equipment. Now, this was in SAP, but this is a very large facility. Put this in place, very simple, gave us quick results, quick information that we could go after. It was incredible. Keep it simple. Dominant failure patterns I mentioned earlier. What are they? We got mean time between failures on an electric motor, cause codes we have in the failure pattern. What are they? Well, operator error, let's say is the highest part of that slope. Okay? The lack of procedure may be the next one. Lack of lubrication may be the next one. Okay? We need to determine, if we can determine what those are by having the right cause codes in place, we can go after those and then bring that infant mortality down. Equipment reliability goes up very quickly. It's all part of FRACAS. So our failure pattern changes from infant mortality to a new failure pattern called random. If we want to get complicated, we can take our data, determine the failure rate on specific components. That's part of FRACAS. Carranza plots, Weibull analysis. There's a lot of tools available to you to do that. I just like to start off simple and then move to more complex if required. Step number 3, we want to know the organizational roles, goals, and responsibility. This is on a RACI chart. Who collects the data, who analyzes the data, who takes what action based on the analysis results. What's the trigger? What's the trigger? And here's our process map for failure data entered. Is the data accurate? Blah, 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 right on through. And on that process map, we developed a RACI chart, as I mentioned earlier. Very simple. Now, any of these slides, if you'd like copies of these slides, I'll show you in my email address. Send it to me, I'll send these slides to you. Step 4, create the FRACAS Policies and Procedures Manual. This is going to be the basis for managing and administrating the failure reporting system that we're going to put in place. And I know this is a tedious step, but we can't skip it because we want to be able to repeat what we do over and over again. In a worst case scenario, we change the policy or change the procedure. And this is the manual we serve for developing FRACAS training for all key personnel. Sure, new employees understand and participate in FRACAS effectively. And it's best to develop a FRACAS management manual and pocket-sized handbook. Working with one mine, and they develop a pocket-sized handbook where maintenance people can have it in their pocket, because some things in FRACAS they can do something about when they're out there on the equipment. What should be in the manual? We want to develop it together to ensure that all parties agree. The manual should have at the minimum the definition of FRACAS, benefits of FRACAS, management's guidance, management's expectation, roles and responsibilities by position, FRACAS reports, key data that we must have in place to give those FRACAS reports. And then when we have these reports, what will we do with them? And then a training outline for each person based on the RACI charts. And that's step 5, developing FRACAS training plan. Each person in the organization needs to be trained in FRACAS. And the FRACAS training typically is going to start with first, once we understand it, and then down to our process maps and our RACI charts. And this is what a training plan, a typical training plan should look like. Consists of position, task, condition, standard, and the condition is the condition under which they're going to be tested. Standard is by which they're going to be evaluated. And what's the method of training? And then the method of validation. What is that? We want to have these in place to make sure when we execute FRACAS, we have the right things in place to give us the right results. Otherwise, we're wasting a lot of money and a lot of time. There are companies out there to sell FRACAS software. Nothing wrong with it. But if we don't have these things in place, that software won't give you anything. And I have to tell you, most maintenance softwares will give you this information. Next thing is implement FRACAS. Let's turn it on. Okay. Publish the FRACAS policies and procedures manual. Train required personnel. Hold required informational meetings. Begin data collection on the highest priority area. So the area, you say, well, we may not know what that is. Go out there with whoever's in charge of production and operations, says, give me your number one most critical area. That's where we're going to start at. And then analyze the data, report results on public FRACAS information board. What that is an information board we want where everybody can see it, saying this is what we have found as a result of FRACAS on this equipment, and this is what we've done to correct it. We want people engaged in it. So we want people to be able to see this information. Then we want to create corrective actions based on the results. We want to mitigate human error. You know, if we need to make changes to the current maintenance strategy, we need to make them. And then we may need to make changes to how production operates the equipment. I know this may surprise you, but there are many failures that have to do with how production operates the equipment. And some of it should have been redesigned, so redesign the equipment. Step 7, monitor, show success, and adjust. We want to monitor the data quality and the results. And then we want to show success. So when we have success, that in the FRACAS program, that process that we put in place, that we've identified a failure, we've eliminated it, and then this is what we've done. We want to make sure people know that FRACAS is working. Okay? Now, if you have questions that you want to ask in this program, just send me an email. There's my website too, maintenancephoenix.com. I will go ahead and post these slides on Maintenance Phoenix. It'll probably be about an hour if I get them uploaded. So just to let you know. So at this time, are there any questions?
That's great, Ricky. Thank you so much. I did have a couple questions come through, and folks, you can definitely still type some over, and we'll hopefully get those answered. But towards the beginning, someone was asking for a little more explanation on the mean time between failure, wondering if you base that on calendar time or equipment run time. They were just saying the statistic can be misleading if equipment is down for a period of time, but runtime data, it's not always available. So maybe you could talk to that a little bit.
Yeah, a lot of people ask me that question. A few different operation organizations, we did some studies on it, and we saw a little bit of difference by just saying we're just going to assume the equipment runs 24 hours a day, 7 days a week. Because it's the number of failures divided into time. So say it's 5 failures in a week, we divide that in 164 hours in a week. That's our mean time between failures. Now what if that equipment is down for 12 hours? What if it's down for 8 hours? You may find in the scheme of things, it's not critical. If it is, then you're going to have to measure it. Or you're going to have to go to failure rate. You're going to have to measure failure rate. I don't like failure rate. I like mean time between failure. It's simple and easy. So to you, try it first using a standard time, dividing the failures into it, and see what it looks like. If you'd like to, send me copies of what the graphs look like, the Pareto chart, or if you got a line graph, whatever that is, send it to me, and we'll talk about it. I'll be glad to help you. All right?
All right, great. All right, another question came in. Someone was asking if you have a template or a ready developed set of failure modes specific to the oil and gas industry.
Yeah, but there's about 5,000 failure modes at a refinery, and with every failure mode comes causes, and they can run anywhere from 2 reasons or causes why the failure mode exhibits itself to 8. So a lot of information. One of the tools that we use is a failure modes mapping tool to map the failure modes to the component. Because think about it, when a motor fails, it's not a motor that fails. It's a bearing. In a bearing, there are about 8 failure modes on bearings. And on those 8 failure modes, there's at least 2 to 4 causes for each failure mode. So it's hard to say, give me a whole list of failure modes and I can identify. A lot of companies do that. They'll have failure codes, and they'll have like 40 failure codes, and they'll say, okay, pick whichever one you think is closest. That doesn't tell me one thing. It doesn't help me at all. So to answer your question, it's more difficult than you think. That's why I like using the failure modes mapping tool and apply RCM, Reliability Center Maintenance, to my most critical assets. Okay, next.
All right. This is more just kind of a statement, but maybe you can talk to it a little bit too. You mentioned the ISO 14224 a couple times, and someone was just kind of pointing out that that's intended for petroleum and natural gas and petrochem industry,
Right.
And just kind of making sure that maybe people are aware of that if they're not in those industries, that maybe that's not the right thing to be looking at, or maybe it does. Maybe you can just kind of talk about that a little bit.
I tell you, right now, like I'm leaving tomorrow to go to Australia, and I'm dealing with 3 different mines, and those mines all use ISO 14224. I've been in food plants that use ISO 14224. Are there some slight modifications here and there? Yes, but we need a standard to start with. There is no standard for food industry. There is not a standard for mining industry. There may be somewhat a standard, but not as specific as this ISO for maintenance and reliability data. So I have used it in multiple types of industries. So don't discount it.
All right, fair enough, fair enough. All right, here's another one that just came in. They're saying that you showed the equipment taxonomy, which is defined in the ISO 14224, but can that be purchased in a format ready for upload to SAP? Are you aware of that?
Yes. But what you have to do is take the equipment taxonomy, look at the equipment hierarchy, and match it as close as you can to what you need. So you can drill down from the highest level. So let's say I have a plant. I've got 5 areas of the plant. So I've got the plant level, I've got the areas of the plant, and then I may break it down to a section level, and from that break it down to the component or part level. So SAP can be set up that way.
Okay, great. And here's a good one. I'm sure you've got something to say about. As you're traveling around, do you find that businesses obviously want to talk about a failure-free operation and get kind of excited about it, but that at the end of the day, you find senior management kind of just paying lip service to the actual practical application?
Yeah, I mean, there is a lot of lip service. That's why I like to start small. And it's to show me, I want to start real simple. I had this problem in Qatar, that very large plant, the whole plant, they didn't really care about this FRACAS failure reporting. They just wanted equipment to run, and they had a lot of failures. But by starting simple, the senior management started seeing the value of FRACAS, and then FRACAS expanded from there. So you've got to show people the value because they've never seen it before, so they're really reluctant to talk about eliminating failures because they're so used to having failures they get numb to it. They may say, my gosh, why did that equipment fail? But to really talk about reducing, the failures that we have or increasing mean time between failures, they really look at you like, you an alien or something. So I agree with you.
Okay. And someone's asking where, you mentioned using a failure mode mapping tool, but where can somebody find something like that?
Send me an email. You see the email on the screen.
Yep.
And I'll talk to you a little bit more about it, because it's a little bit more than what I could talk on at this time.
Okay, all right, so everybody sees that email there. Another one came in, is there a clear difference between a malfunction failure and a trip?
You know, it's a good question. I tell people to start with, we got to identify what a failure really is, because we have functional failures, we have partial functional failures, we have total functional failures. What are they? You know, and we count a failure if the equipment is not operating to specification. Good question. That's what I like to sit down with senior management and discuss this before we get started. Because until we come to a definition that everyone agrees on what truly is a failure, how are we going to mitigate or eliminate failures? We're not. We're going to be what I call chasing failures. We'll be chasing failures every week forever.
Okay. And someone looking for clarification on what the acronym MAERR stood for.
So that was maintenance error. That actually came from a plant. That was maintenance error. That was off of SAP.
Oh, okay.
That was in Kazakhstan, believe it or not. They the data quality they get is very high. They demand it. And I say, you guys, if anybody was on here from Kazakhstan, I'm not taking anything away from you, but if we can do it in Kazakhstan, we can do it anywhere.
All right. Okay, well, that seems to be it for the questions, but obviously you've been kind enough to put your email address out there for folks. So, you know, any questions that you guys have after you step back from this session and kind of digest it a bit, you know, certainly email Ricky or email us here at UE Systems, and we'll get those questions answered for you. But thanks again, Ricky. Really good information, and as you guys saw, he also said he's going to put those slides up so you guys can download those from his website, and we will obviously put this recording of this webinar up on our website and alert you all to it once it's up there. So again, just a great session, Ricky. I've got a few kind of housekeeping slides to follow up with you all on here as we close out the session. You know, in addition to the resources Ricky provided, we obviously hope that you'll visit our website, uesystems.com. We've got a ton of information up there on all kinds of the different applications for ultrasound. We've got all of our webinars. We do these every month, so all of those recordings are up on our site for everybody to access. We really do try to be a resource for you, so visit our site and use us as a tool.
And Maureen,
yeah.
One thing I recommend, if you don't do anything else with UE Systems, buy the lube caddy, because what that is for is to lubricate bearings the proper way. And if you do that, you saw what happened to those 900 electric motors. That's what that one plant did. That's all they did was use ultrasound for lubrication.
Well, we appreciate that little advertisement there, and I promise we did not pay him to say that, but thanks for that vote of confidence, Ricky, and obviously you guys can see more information about our grease caddy up on our website. Some other ways we hope you guys will stay connected with us. We've got our UltraProbe users group on LinkedIn. That's a great place to bring some of the discussions from today, questions from today, over to our users group and get answers from advice from your peers. We're on there monitoring it and answering questions there as well, so a good place to keep in touch with us. We're also on Twitter at UE_systems, and we've got our sound advice blog, uesystemsblog.com. We've actually got a few new posts up there geared towards safety, so we hope you guys will check those out. And just a couple dates to throw out at you. It's right around the corner, but there's definitely still time to make plans to join us in Clearwater for our 9th annual Ultrasound World Conference. It's going to be a great event. We've got a really good lineup of presenters sharing best practices, great networking. So if there's any way you can come down, we'd love to have you. And we're going to follow Ultrasound World up with our next webinar next month on May 22nd, where we're going to kind of do a roundtable discussion about the lessons learned at Ultrasound World 9. So, so if you can't make it to Florida, hopefully you can at least join us on our webinar and get some of that value. And I'll just leave this up here, all of our details, how you can reach us, our phone numbers, website, and we hope you'll join us next month. And again, thanks, Ricky, and hope everybody has a great, safe afternoon, okay?
Thank you, everyone. Goodbye.